Hello, everyone, and welcome to this 8th lecture. Today is the last lecture of the Chess Party project. So today we're aiming to, instead of just teleporting our pieces around, we actually want to move them smoothly using AI. And with that being said, let's not further wait for it and just get right into it. As always, right before we start, let's first have a look at our current project progress. So we are still in the BP part, which contains the chess moves, and our last thing we implemented in the last lecture was the move selection via clicks. So the actual chess pieces are now teleporting around. Today we will go with the AIMoveTo, so smooth out the moves, learn what Niagara, for example, does, and also implement some pretty cool features so the chess doesn't look as boring anymore. Let's start with a quick recap. First of all, we have two lesson relevant parts, the chess and the darts. As I mentioned, this will be the last lecture, which refers to the chess project before we advance to the darts part. And thus we have relevant files and usages already built together. We build up the chess AI, we build the chessboard, and we build the chess piece together. We now know what those functions do and how we can actually use code within our blueprints. We also have checked the relevant game blueprints and their usage. We know what the game mode does now. We know what the game state chess does now. And we've also seen what our player controller is good for. And the next blueprint we want to have a look at more specifically is the chess piece blueprint. We have seen the chessboard blueprint now. We have extensively used the chess tile the last time. And now we head on to the chess piece. The last time we included the moves by clicking, and let's have a quick look at what we can do now. So the chessboard pattern was part of the 5th lecture, the spawning of the chess pieces was part of the 6th lecture, and now we are also able to select our moves based on the position of our mouse. So when we click, we can select this chess piece to be moved. Then we can select that we want to have that field to be attacked, and once we click onto it, it just moves there and everything should work as intended. Same for here, you can see Stockfish immediately does his move, and we can have a very quick recap on that as well. So everything that happens will be started from our content drawer, and there we have the blueprint game mode chess. We just have the event graph here. We have our game state, which we just paste into a variable we call onInitialize in the chessboard. We destroy all chess pieces. We pass our fence string, which we just get from our game mode. Then we spawn the chess pieces on board, and once that's done, we call the game mode with the next move, and the next move is just an empty one here. So we just convert this move to a lower move, then append it to our fence string, and now we just switch the player. But if it was White's turn, it's now no longer. Then we print the fence string just for debugging reasons. We call the get AI feedback with a certain skill level. We also get our provide our fence string in here so Stockfish can get us a corrected fence string. And then we get out the best move, the legal moves, the is checkmate and is draw variable. And in this case, if we have a checkmate, we just print that we have a checkmate, wait for 5 seconds and reload the map. If we have a draw, we also print a draw offer and then call the delay, which lasts 5 seconds, and then the map will be reopened. Now we have to behave differently when we have a player that is an AI. So if we have a player that is an AI, we wait for 0.2 seconds before we adjust the best move to a legal move. Let's quickly go into here. We go to our game state chess. We extract the fields so we know now our start and end field and set our legal moves in the game state. We also set our current start and our current target, and then initiate the attack, which just disables our mouse over events, switches the state to currently moving. Then we get the actual move from the legal moves just to ensure that we can work with it, and then initiate the attack over the chessboard. And if the length is bigger than 4, we have something which is called pawn promotion, or passant, or castling. And then if this is not the case, we have a normal move, so we just get our target location, our start field, our end field, and our present chess piece on that tile with that macro here, and then we call attack inside our chess piece, and here we have our actual location being set to the target location, and then we call on attack finished, update our board, and get the move out of there, and initiate the next move, which just disables the attacking mode and sets our state inside the game state back to inactive, and also the game mode chess will be called again with the next move being provided with our constructed move here. And then we do this whole thing from the start again. If we don't have an AI, but a player, we extract the legal moves first. So we reset all legal moves for all board tiles, so they are just empty. Then we iterate over the new legal moves and add the legal move to the according board tile. We simply search for the starting point of this move and search for it in our fields. Then we check if it's valid. If it's valid, we cast it to a chess tile and add this move to our legal moves of this chess tile. Then once all of this is finished, so all the chess tiles now have the legal moves added to, we go back to the game state, set the state to inactive, and then we just get our player controller, check if it's valid, and enable the mouse over events to actually be able to select our next move. After that is done, we can simply hover over the chess tiles, and once we do that, we just check for the correct state here. If it was inactive, we can now set the state of the chess tile itself and all the legal moves of this chess tile to be highlighted. If we end the hovering over, we will just go back from highlighted to inactive for all of the fields. And then when we click onto a tile and we use the left mouse button for it, if the state was currently highlighted, now it will be selected. So we turn from light blue to green and we set our current start to this field and our legal moves, which are contained in that chess tile. And that will be set in our game state chess, so we can move it later, use it later on. If we don't have a highlighted state here, it could be selected. If it is selected, we just check if the move is actually in the legal moves. So we just check if our target field is included in the legal moves. If we found it, you can see that here, we just set our current target to the field name of the chess tile we currently clicked on, and that will be done also in the game state chess, and then set this chess tile to be under attack as our state, so it turns from green to red now. And once the state is under attack then, and we left click again, we will reset all tiles, so everything will be set to inactive again, and inside the game state chess we just call the initiate attack again, which then calls all of this logic, and it allows us to attack by using the logic of the chessboard and then providing all of the moves. And let's quickly click onto it and then attack with the chess piece that's according to that move. We also have included a more convenient solution for our users. So if we don't press the left mouse button, we go into the false tree here. And if the false tree ends up in the correct state, which should be selected, then we reset all tiles to inactive, so we can just select one again. And if we are in the state under attack, we just reset all legal moves to be selected. So we have actually turned from red to green, and here from green to not visible at all. That's our current logic implemented. And now we have some extra stuff to have a look at, and that's namely inside the chessboard, we have to check what is done inside the check for pawn promotion and check for EnPassant before we advance to the chess piece. Now that we are a little more used to blueprints, it's easier for you to understand what these checks are actually doing. So let's quickly have a look at the check for pawn promotion. What we're searching for is inside the move if we have an arrow in there. And if we have an arrow in there somewhere, we just get our target location and chess piece from move, as we would do with a normal move as well. and return then the target, the destination, the start square and target square, which is just the start and end field, as we already know. But we also give back our promotion, and that promotion is located at the start index 6. So let me quickly show that to you. If we go for a print string again, and we have something like A7, A8 turns into a Q, then we have the A7, A8 as our moves here. The start field would be A7 in this case. The end field would be A8. So quickly let me show that. A8 would be our target square. And then our promotion would be from start index 6. So 1, that would be 0. 1, 2, 3, 4, 5, 6. And that's the letter we would just return because we check for the length 1. So we would get, for our promotion, the Q here. All right, next thing we can check for is if we go to the chess piece and to the initiate attack, we check for the en passant. And here it's quite necessary to do it this way, because if we would check for the en passant before we check for the promotion, which you can see here, that includes already a minus, right? So if we would check for a minus before checking for the arrow, we would always end up with a en passant instead of a promotion, and that's not what we want. That's why we have to actually call the pawn promotion before the en passant check. So if we have a minus in there, we just get our moves. That's nothing special here. But here we have something special where we just use the start field and not the end field. And that is due to this reason. If we just have a look at a simple move here. So let's go with A4, B3 minus A4. That would be a valid move for an en passant. So that would be our start field. That would be our end field. And that would be the field we have to get rid of. So let's quickly check that. Start index of 5. That's 0, 1, 2, 3, 4, 5. So the next two would then be our en passant square, which we just give to that event here. Don't worry too much about the event yet. I will show that to you once we are in the chess piece, because that's where it's located, as you can see here. If we check for castling, we have to check for this pipe here. And if we have a pipe included, we just get 2 moves out of it. And why is this the case? So first of all, if I go for a print string again here, we would have something like this, E1, G1, and then we have the pipe H1, F1. And that's just our logic. I changed the syntax together with you. I already showed you that I changed the syntax. That's because we can't get a castling move from Stockfish. And if he just provides us with E1, G1, we would miss out on one move, which would be the move of the rook here. So in that case, we get the start field for the king, which would be E1. We would get the target square of the king, that would be G1. And then we would have our second move from H1 for the rook to F1, which would be the location, the target location for the rook. And that's what we do here. So first of all, we go from 0 and 2. That's our normal procedure here. Then we have the target location for the king and the start square and target square of the king. And then we check another time for the target location. And we check from 5 to 7. So let's quickly check that. We have 0, 1, 2, 3, 4, 5. From here, the next two would be our start field for the rook. And those two would be our target field for the rook. And that's exactly what's happening here. So we have the present chess piece rook, we have the present chess piece king in this case, and then we just have the start and end field of the rook and also 2 target locations because we have 2 moves inside of 1. Good, now you know the whole movement logic here and also how the check for castling works, and now we can actually move on to the chess piece. So the next thing we want to check on is the chess piece. Let's quickly go into that. So we go to the content drawer, then we go to blueprints, then pieces, And now we go into the parent class, which is this BP underline chess piece here. So simply double click it. That's not where we are currently. Let's go to the event graph. And here we have our attack logic, and we also have our custom events here, which are the en passant, pawn promotion, and castling. And to show you how you can actually set up a custom event, you can just right-click here and then type in custom event. And then you can just add in a custom event, name it like you want, for example, test. And now you could also provide inputs to that. For example, we could go with an input like a Boolean, and then you can just call it from anywhere else. Let's quickly call it from, what would be a good part? Let's go from chessboard. Let's go to our chess piece. So we just take the present chess piece and then we call the test event. You can see I can now call the event here and tick the parameter. And now I would have this parameter to be set to true on this test event from the chessboard itself. So that's how you can set up a custom event very easily. And let's have a look what those custom events actually do. Because what we have to look at now is how we can actually set up events for only specific chess pieces. And that's inside the content drawer as well. And you know, the bishop just doesn't have any special move. The king has one special move, which is the castling. So quickly check onto that. And you can see the logic inside of here compared to the logic inside the bishop, which doesn't even have a logic. But if I open it up, you can see we just have those three functions, which are overwritten by the parent because we don't have anything to overwrite here. But the king has also those three functions and two more. He has the event castle. So first of all, we want to tick castling. So we're castling at the moment. And then we want to set the rook reference to the chess piece reference of the rook in here. We want to set the target location of the rook. We want to get the start square of the rook and set it all into here before we actually attack. And then we just call attack on the target location of the king and the start square of the king. So he would just move to that field for us. But after that, we call the attack event, which would be here. Sorry, it's not overwritten. That's because that's why we wouldn't get it inside of here, but instead here. And then we call on attack finished. And since we are still in the king class, we would call this event on attack finished because it's overwritten in here. And we would check if castling was true. And if castling is still true, then we set castling to false. We would get the start and target field, update the board and get the next move, because we still have to change the position of the king for our board logic. And then we would cast this rook object here to a rook chess piece. And then we would just call the tower to attack by its logic. So we have here the target location. We provide that to him. We tell him his start square. We tell him his target square rook. And we also call him which move he should then send out to our game mode afterwards. And that's what we do in the tower attack. Otherwise, if we don't have a castling move here, we simply update our board and get the move and initiate the next move. So that's nothing special. You can see it's just the same logic as we have here, but we have to override it. Otherwise, we can't add that part to it. And in the tower attack part, we can have a look what that does for us. So inside the tower attack, we first of all set the rook to be attacking. Then we set the actor location to the target location. And then we just have the start field, target field, and the move. So we update our board and get the move. But instead of using the already created move, which would be created inside of that logic here, we use the move provided by the king, because Stockfish can just work with the king move and not with those two moves at once. And then we initiate the next move. And then you can see that's still a mess in here, but let's quickly fix that up like this. All right. And then we just call our initiate next moves and start the next move on our game mode. that was already the most advanced part because it includes 2 moves in one. And when we go back to the event graph now, we can see we still have our en passant and pawn promotion happening. And the en passant and pawn promotion event can only be called on a pawn because the pawn can advance or be promoted to something else, and only an en passant can happen on a pawn as well. So let's go to the pawn. We just can open up our content drawer, make sure we are in blueprints and then pieces. And now we have our pawn, which is right here. Let's double click it and have a look at that. So we can see all of the 3 functions are still overwritten. Nothing special about that. But here we have an en passant logic, and this en passant gives us an en passant square, and we just set it to another value. So if we have an x in here, that's just the standard value. Then we know that no en passant has happened. Otherwise, we would have something like, for example, a4 instead of the x here. Then we call attack on our chess piece again. And for the pawn promotion, it's basically the same. We have a promotion being set to x, so no promotion at all. Then we call attack, and this print string is not necessary. This hello is not really necessary at all. We can get rid of that. And now we have the on attack finished. And once again, quickly have a look at the chess piece. So we are still inside the pawn and call then this on attack finished. That would be the parent on attack finished. But we've just overwritten it in here, and we still provide the start and target field for that. Now, if the en passant square is not an x, so we have actually an en passant, then we have to update the board on en passant, reset the en passant square to x, and then initiate the next move. Let's quickly have a look at what the update board on en passant does. So as you can imagine, it's one more step than normally. So we have 4 executables here. And we start with the start field by name. Then we get the present chess piece from there, call this chess piece to move, and reset the chess piece on our current tile, on our start tile, because we moved it, of course. That's the same logic as before. As well as here, we move our chess piece, which we want to move, to our target field and set it as the new present chess piece. But now we have another part included in that. And that's just this en passant square, which we searched for. And if this field contains a present chess piece, we cast it to a present chess to a chess piece to ensure that it's actually 1. And then we call captured on that chess piece. And then we set the reference of the present chess piece to null here because there is no chess piece anymore. So we have a move that looks like this. We have one here. The other move went up like this before. Now we have one move here and one move here. And now we move like that and want to get rid of this part. So we call that part here captured. And what does the captured event do for us? Let's quickly have a look at it. It simply destroys the actor. So that's what the promotion the en passant logic looks like. And then we just create our move as before, because we don't need that minus in here anymore. And then we return the move and initiate the next move afterwards. The next thing, which only happens inside a pawn, is a promotion. And let's quickly check the chess piece for that. So we have here our pawn promotion event, and that is called by our chessboard when we have actually inside of our initiate attack here a pawn promotion. So quickly go into here. If we have an arrow inside of our move, we know we have a pawn promotion, and thus we will just extract the promotion from that part, which would be a Q here, and then call this event. So then we call the event inside our pawn. And you can see we first of all set the promotion to the promotion we just received. So instead of an X, it would be a Q here now. And then we would simply call attack because it's nothing else than just a move. Everything which is different happens afterward. And now we go on to the event on attack finished again. We have checked that we don't have an en passant. You know now how this part works. But if we have a promotion, as I mentioned, this won't be an X anymore, but instead a Q or something like that. And if we have, then something, we want to show a promotion, or if we have a promotion happening, we want to show the promotion if we are a player. If we don't have a promotion or an EnPassant, we simply want to update the board and get the move from it and initiate the next move. So basically the same logic as it is here. But if we have a promotion, we have to do two things. First of all, we have to check inside of our game mode if our current player is an AI. If this is the case, we have to update the board on pawn promotion. And let's quickly show you what that is. So we go into here, and then we update the board on pawn promotion. So we get our start field, and then set our present chess piece to not there anymore. Then we despawn the pawn, which just moved, and set we set the despawn logic to active, and that will be implemented in a second, so you will see what actually happens there. And then this cool Niagara effect shows up, and afterwards we get the square by name. And then we call on pawn promotion initiated. We get the field to spawn on, so that's our target field. You can see that here. We take our target field and search for our tile where we want to spawn on. We take our promotion, and then we initiate this on pawn promotion initiated, and also create a move. And this move just includes the moves, then the start field and the target field and the promotion. So we end up with something like this, print string, and then we have something like A7, A8 into Q. So that would be what Stockfish would receive from us. So he knows that we want to advance to a queen. Then on pawn promotion initiated, we go back to our chess piece because that's included in here. Now we wait for 3 seconds and then destroy the chess piece we just want to destroy. So quickly have a look at that. We want to destroy the pawn and instead then spawn a chess piece based on the Fenchar. And that's the logic we just wrote together on our actor location of the field. And let's quickly go into that. That's our logic when we have a Fenchar like, okay, wait a second, it's already opening. Okay. Here we have our spawn chess pieces based on Fenchar. That's the logic we just wrote together. So we get a Fenchar and we get a vector of the field location. And then we just spawn in, that's right in here. We just create a transform from the look direction and stuff like that. And then we spawn the actor in. The chess piece class we just referenced by our Fen character. Let's quickly do a recap of that. So when I enter not chess piece inside of here, but that's all inside chessboard. So let's go into here and search for chess pieces. Chess pieces, here get chess piece classes. And when I now search for that, you can see if we enter a Q here, we would just spawn a queen on that field. And if we enter a R, for example, it would be a rook and so on. So you know that logic already, but it's just a little bit more advanced than before. And that's just what we call. Now let's go back here. So we spawn a queen in, for example. We check if the spawned in actor is actually a chess piece. If it is a chess piece, we set the field, which we just have the reference here. We set for this field the present chess piece, and then initiate the next move with the move we just created. So in this case, it would be A7, A8, Q to initiate the next move. And that's just what we have to do. So we have to despawn our pawn and spawn a queen instead of it. And that's the whole logic which happens on pawn promotion initiated. Let's go on with the interactive part. First of all, we want to include AI movement, and I guess you will be surprised how easily that is possible inside Unreal Engine. To do so, we first of all click onto the content drawer here, and then we go into this path and go onto the chess piece. And now we are already at the right function or event in this case. So we have the attack event here, and we just set our actor location based on the target location we receive from here. So first of all, we have to get rid of that because we don't want to teleport anymore, but instead move via AI. Then we hover over this exec, drag out, and just call AIMoveTo. And now we have this function here. Let's move everything aside a little so it doesn't obscure anything. All right. And now we have the option to set a pawn we want to move. In this case, we simply drag out and call self. We want to move the chess piece we're currently in. And as the destination, we want to set our target, which we receive from here. The acceptance radius then tells us how precise we want to go there. So it will stop 5 points in front of the actual destination, and that's okay for us. And we can also tell it to stop on overlap, which we don't need in this case. We also can check the movement result, so that's just the enum, which could be something like moving and so on. It's not our selected enum, but a different one, which Unreal Engine provides to you itself. And then we connect on success with on attack finished, and with that, we can already go on and just start here, spawn our things in, and now you should see that when I select our move like we did before, it moves now via AI instead of using the teleportation. That's also the same for our knight here. But that's not fail-safe yet, because it can still be that something, let's say, blocks our way. So for example, I could just take a nav modifier volume here, then we move it to 0, 0, 0, and I move it onto here. And what you can see is it rebuilds our navigation. And what's that, you might ask? That's a good question. So to answer that, simply click into the viewport here, and then press P so you can actually see your nav mesh. So that's the nav mesh we currently have inside of our field. And you can see it just covers everything except for this part here, because that is the nav modifier. And when I reset it, it's actually not showing this bug anymore. It actually covers the whole field and not just parts of it. This nav modifier volume now tells us that we can't move in that area. And you can see when I move that around, the navigation gets rebuilded. And that's just what Unreal Engine offers you to actually have an AI movement logic implemented. And as you can see, it's nothing more than that. To actually let an AI move, we now have to know where we can find this nav modifier volume and so on. In this case, we want to have a nav mesh bounce volume. So let's quickly reset it to 0 again. And now if I move it out, you can already see that this part here would also be movable now. And that's just how the AI knows where it can move to. The parts which you can then adjust is one, this nav mesh bounce volume, where you can just set the actual scale. So look, if I just make it bigger, pretty much bigger, you can see it adds something here. So you can just set the area you want to be able to move in. And you can also set some different parts, but that's in another component here. And I have to get this outliner. It's not like this, but like that. Okay, perfect. And when I now go to the recast nav mesh, which actually determines how good this nav mesh is created, you can see I have a lot of options there. I can draw stuff, but that's just for the display here, so I will skip that. You could also draw your tile pool size, so that would allow you to only set a certain amount of tiles. And we can also set our tile size, which is just the precision with which the actual chess piece can then move. Then we have the agent radius. So this radius is just how big should our agent be. And if you turn it to 0, for example, and imagine this would be a wall here, then you would just be able to move exactly to the wall and not just stop 35 points in front of it. The agent height is then the height of the agent. So imagine something would block the agent here. It can't move there, so no nav mesh would be created there. And for the agent max slope, you can just determine which angle this agent is able to move. So for example, if you wanted to move a hill, make sure that the slope is high enough here so it can actually walk there. The other part here is not as interesting. You can force a rebuild on load, that's down here, but that's nothing pretty interesting for us. And the runtime generation is static in our case. So what that means, we can just build our paths by clicking on to build, then go to navigation and then build paths. And you can see now those paths are already built. So if I move it out, you can see it just changes automatically. But what happens here now is when I start, you can see everything spawns in as usual. You can also see it's nothing very special here. But once I want to move the chess piece here now, you can see it can't move anymore because the nav mesh is not provided for it anymore. And to show you what's happening then is just that we have this onFail method here. So in this case, onFail would be called. Let's print it. And it would just tell us, okay, let's call it nav moving failed. And now we would just print moving failed whenever we move here. So you can see it works without any problem for the chess pieces which have a nav mesh underneath them. But for example, for the knight here, that shouldn't be the case, and it tells us moving failed. And just to make sure that it at least tries to do it multiple times, we will add something here as well. And that's from the onFail, we will just go into a retriggerable delay. And from there, we want to go from the completed back into the AIMoveTo part. And what this allows us is basically that we are able to now retrigger this AIMoveTo after a certain time. And that's exactly what we want to have. So for example, let's do it like this. And now onFail, it will just try to retrigger it. And you can see that actually by printing the string here. Let's quickly do that as well. So let's do this. And no, sorry, not like that. But instead we should do it like we move it here. That will be a mess now, but don't worry too much about it. So we will just connect this and then that. Then we wait for it, and now we will see it's called multiple times just as a failsafe if something is happening. For example, if something blocks our way and it moves out of the way, we should be able to move again. So now you can see moving failed, moving failed, moving failed, moving failed. And that's just because we recheck if we can now move. And that's what we want to add here. So let's get rid of this print string, just call retriggerable delay. And now we can ensure that we can actually move to our target. And this will only be called once we are actually there. So once we are within the reach of this 5 points here, it should be doable and it will be called as on success finished. So if we remove it now, we can just go into here, spawn everything in, and our chess piece should be able to move again. Let's quickly check that. All right, you can see it moves and it calls not moving failed anymore. So we have just assured that even if something blocks it, it will still try to reach its destination until it is totally blocked. The next part, which might be interesting for us, is how we can actually move a piece which would have to jump. So a knight, for example, a rook, it doesn't look good when it just moves through each other. We can definitely do better than that. And to do so, we go into the content drawer, go into our chess piece, and this is our logic for the attack currently. Now we need another event, and we can just add one. Don't do that now, please, but you could add one doing this add custom event, and now you could use that and set up all of your inputs, but instead we need the attack event to be copied. Now you can see it automatically renames to custom event because you can't have 2 events with the same name. And we just call it jump and move. That's what we want to call our event here. And from there, we just do the same as we did before. We just set our attacking to be true. And then we add a timeline here. And you can only do that in an event graph. So please keep that in mind. And then you can add a timeline. And this timeline should be played from the start in our case. And when we double click onto it, we can add tracks to it. So in this case, we just add a float track. Let's call it height. And with that, we can just adjust the height. So if we now hover over this float track here, we can right click and say add key to curve float 1. Let's do that. Now we can set our value. We want to have value 0 at time 0 and at 1 second. So time 1 second, value 150. That should be our second part. So we just move the piece up, and that's just what we do in here. We can also adjust it a little. So if we go onto here and go onto user instead of linear, we can just change the angle here, which we should take. So you can see it can bend in any direction, but we want to smooth it a little bit so it doesn't just go full ham to the top and then back, but instead moves very slowly at the beginning, goes a little faster, and then it just ends up on this height. So we just compile it. Now we've set a timeline which we can play, and this timeline allows us to set the height in the update function. So we have an update function here, and we can just call the event which is inside the move selection part here. No, sorry. Yeah, inside here. The lesson 8 AI movement, which is called adjust height. So we just call that event on update and add our height to it. And now we can check what this actually does. So one thing we want to have to jump and move is our knight. So in that case, we just go and call attack event here. We want to override the attack. So event attack here. And then we just drag out from here and call jump and move. And now from there, we just have our start and target field, and we want to move ourselves. So on the event attack, we just jump and move instead of only attacking. All right, make sure everything is compiled and saved. And now if we try it again, you will see what actually is happening with our chess piece, in our case, the knight. And once we click onto the knight now and select this, you can see it moves up and it doesn't move to the location currently. But that's just what our adjust height does here. And here we have two things to consider. First of all, this adjust height is doing a relative offset. So what's happening in here is, for example, if I show that to you in the viewport and I just click onto my static mesh here, I just don't do anything special except for moving this piece up and then moving it down again so it doesn't collide with anything on its way. And why is this necessary to be relative instead of world position? Well, the thing is, you need to have the collider on the ground to actually have enough mesh movement, and that's here inside the character movement. Let's quickly go to the default layout because it's not the default layout I'm currently having here. All right, now it is. And here you can see inside the blueprint up here inside my components, I have a character movement, and that's depending on my nav mesh. So I have that character movement and I need to have something which at least hits the ground. And if I move my mesh up, let's go to the static mesh and move that up, it wouldn't hit the ground anymore. That's why I have a collider here and another collider which actually has the collision route here. So I can move it from the collision route up and not hit anything on the way anymore. That's a workaround, but that's a very smart workaround because you will now be able to move enough mesh even though your piece is not on the ground anymore, because you just moved it in the relative location here instead of the world location. All right, that's also fine. Let's go back to the chess piece event graph. And now we have adjusted the height. And now we can simply go on and just take our AIMoveTo from up here. Just copy it down here. We go with the finished here into the AIMoveTo. And now we want to also set our destination to here. The pawn is still a reference to self. We want to move us there. And now what happens would be simply we have our chess piece here, our knight, and it will move up and it will move to its location, but not down at the moment. Let's quickly check that. We just go up and nothing happens afterwards. So there's a logical error. Actually, there's not. You see it now moves there, but it doesn't go down. And that's exactly what we intended. The next part here is that we want to now move the piece down again. So on success, we just drag out again and add a new timeline. And we just add a new timeline here. We don't want just to play it. We want to play it always from the start. And now we click onto it again. We add a drag. We add a float drag. And here we set our key. And that should be times 0. Value should be 150. So the other way around we had before. And now we want to have a second one, which should be key float 2. Let's go with time 1 and value 0. So we move back there. Now let's quickly take that into place again. Go on to here, tick user, and you will have the option to actually smooth it out. All right, this didn't work. Let's go back to linear. Now we can't move it. If we pick user, we should be able. In this case, we aren't. Let's go with auto. That also doesn't work. Interesting. Maybe it's because I have to do it here. Yeah, that's the point. You have to do it always at the beginning, and then you can have this smoothing curve here. All right. The next problem which we just faced was the time we waited before we actually moved, and that's just because we set the length to 5 here. So we just shorten it to 1. We also go onto our other timeline and tell it to be only 1. And now we have a timeline which only lasts 1 second. And in the event graph, we will now have our chess piece moved up, then it will move to its location, and then it will just move down again and do nothing else at the moment, but we'll fix it up in a second as well. Oh no, actually, I forgot something, and that's the update part here. And for that, we have to also call adjust height. And in this adjust height, we just do the same thing as before. We just set our collision route as the target and then set it up a little bit higher than before. So actually, we can move our chess piece by still having our object on the ground. So now it should work. Let's quickly check that. And then we can add the last part, which is just the on jump move finished. That is another logic we need to include here. And that's just, let's move it here. You can see it moves up now, it turns its direction and it goes down. And that's just what we want to have. But now we want to have one more thing. And that is when we are finished, we want to call on jump attack finished. And you can see that's not included yet. So let's collect both of those and just copy it down here. Let's rename that to on jump move finished like this. And now we need one more field, and this one more field has also to be a string. So quickly add that by clicking the plus here and call it move. And now we just have this part inside of here, which we can compile and save, and now it shouldn't trigger a warning anymore. And that's just a different ending of the jump of the move. So now we can call here on jump move finished. And we just give our target field. Let's quickly put that a little bit higher so we have enough space here. And then we just add our start field and target field here. And that's it. Except for one thing, we also need to include a move inside this event here. So we also add a move here to then be used down here. And that's quite tricky. The move should be connected with here. So we actually have our move finished. Now we have to consider which of the pieces actually have to move or to jump and move. And let's quickly check it. Our knight should be able to do so now. So that should be definitely the case. Let's try it. And it should also trigger the next move of Stockfish. Let's see. It goes down. All right. And the other knight moves up and moves over and moves down. So that's just what we want. The other piece, which is still missing because it can also jump, and that's only one part, and it's the castling move of the rook. So inside the rook, we don't call set actor location here, but instead we delete everything here and call jump and move, instead of the tower attack here. And then we just call those moves as the target field, and that's it. So the tower can actually move. All right, the next part is then that we don't only have a tower attack, but also a normal attack to override. So let's go with the attack here. No, not like this. We have to take the attack event. That's two different parts. If you have an attack, you can call that event by the call function here, or you add an event by going up here. And then you have the event attack. And if we attack, no, sorry, we only need that for the tower attack. Only this tower attack should be jump and move. And that should already be enough to make the tower move where we want it to. So now in that case, let's ensure that this is also working. Let's quickly try to get a castling move together here. That should be doable like this. Now we go here. And then we move the bishop out of the way. And now we can actually do the castling move by selecting the king and moving here. And now you can see the rook goes up, goes over, and triggers the next move of Stockfish. So that's the whole movement logic we want to implement. Yeah, and that's it for now. Let's make it a little bit more fancy. Let's just check what options we have to make it even more interesting for a player. And first of all, we have the option to add a Niagara system to our game, and that's a particle system. That's the Unreal Engine particle system. And you can simply add one by right-clicking into your content browser, and then you have your Niagara system here. You can also have just an emitter, which you can have here. Otherwise, I always recommend Niagara system, but please be careful with the usage of that. If you use too many particles, that can, of course, create your performance. Okay, so please keep that in mind. And then you can just have some of the already included templates of Unreal Engine. I, for example, like the particles unique ID here pretty much. So let's create one. Then simply click anywhere to get it set as new Niagara system. Now we can click on it, and you can see this is our particle system here. And you have a lot of options, but the most relevant ones I want to show to you. So you have the option to set the length right here in your timeline. You could just get that part and put it to 1. But please also have a look that the time doesn't stop here, but here, or actually in this case here. So we could move that forward, and now the animation would play only from there to there. And that's just how we could set it up. Let's redo it, and let's have a quick look at the new Niagara system itself. So what options do we have here? We have some system properties like warm-up time. Do you need any warm-up time? Loop behavior. Do you want to loop only once? So that will look like this. Only one loop, and then it doesn't do anything anymore. In this case, it's just to show you. Otherwise, you could have infinite, and that's the normal part. You could have your loop duration set, and you could recalculate your duration after each loop to make it a little bit more customized. The other parts you can find are down here, where you could set any of those. You can see which ID they have and which part they are part of. So that's an engine part, that's a system part, and so on. So this belongs to that. And for example, let me try to find one which connects to the emitter. Okay, there's nothing in here at the moment, but that's a system part, so it will belong to this part. The emitter itself, then, we have a lot more options. We could call local space here. That's quite interesting for us because that would then be the relative location and not the world space. And then we also have other options like life cycle mode, loop behavior. That's exactly what we have here. So if we change the loop duration here, we can set it to 1 and it would do exactly what we expect. But if we change it inside the system here, you can see it won't have an effect at all. It's just because I changed it here. Let's quickly change that back to 5, I think it was. Let's redo it. Yeah, it's 5. And now you can see it's working again, even though I set another loop duration for my system here. All right, the next part is then that we can select if we want to have it CPU simulated or GPU simulated. Just keep it like this. I haven't changed that any time, and it's really not a matter of performance, I'd say. At least I didn't have any problems with that mode yet. Then we have scalability mode. We could scale it over itself. We could change the spawn rate so it spawns way more in here. Let's quickly do that and have a look. You can see now it adds 1,000. And that's just how this particle system would work then. So it spawns way, way faster than it should. And with that, it looks just cool with 50. Then we have the lifetime. We could change that to 1. So now I have a look how fast it gets deleted afterwards. If we set it to 2, it will stay a little bit longer before the particles are getting destroyed. And you could also set colors and stuff like that. You could change the sprite size. That's what I did for our project. I just put it up. I think I did something like 10 or something. So you can actually see it on the chessboard and it looks pretty cool, in my opinion. And yeah, I think it was 10. That's right. You could also change the shape which it emits from. So for example, I could change it to hexagon here, and you would see it now has the emitter set as a hexagon. You could also do some different thing like a sphere. For example, now you can see it just spawns inside a sphere, cylinder and stuff like that. So, that's just an option for you to change and whatever you like. You could also adjust the ring radius to 200, for example, then it's just bigger than before. That's all, nothing special about that. So just as you would imagine. Distribution could be random and stuff like that, or you have it directly aligned with your shape. And then we also have the option to do some different render strategies, sorting modes and stuff like that. But actually, it's way too much to explain it here in detail. So I will just skip that for now, and I guess you should play along with it to get a feeling for your own what it actually does. It's just too customizable to explain every single option you have in here, and I guess I even don't know all of them, so I just skip it here. So how can we use it now? And we are actually using it at the moment, and that's inside our pawn promotion. And when we go to the pawn promotion, we have to go to interactive media, chess, blueprints, pieces, and then to our pawn. And now you might wonder, where exactly should that be located in? And as I mentioned, it's inside the promotion logic. So if we go to the promotion, show promotion of player, we have actually this check for our current player. So if our current player is an AI, we just update the board on pawn promotion. Let's quickly have a look at that. So we just get our start field and get the field according to it and set the present chess piece to none. And now you can see I just enabled the despawn. And you can see this despawn is not a part of my actual parent, but I just added it to the pawn. So have a look at a chess piece. There is only a destroy, not a despawn. And this despawn is this Niagara system I just showed you. So let's quickly activate it. Go to viewport and now auto activate. And you can see that is just what I showed you. That's our despawn. So we can then promote it to another piece. And inside this logic here, we just set it active. Then we get our square by name and call onPawnPromotionInitiated, and that's just triggering the 3 seconds delay and then destroying our actor. So the Niagara system has enough time to play before we are destroying the actor, and together with it, of course, the Niagara system, which is attached to it. The other part where we can make everything look a little bit more fancy would be if we just add UI. And that's already done for you as well. So if we update the board on pawn promotion, and if we have a look now at the branch where we actually, show promotion if player. When we are a player, we want to decide ourselves what we want to spawn in instead of our pawn, right? So we just construct a UI that's called as a widget inside of Unreal Engine. And we can construct it by simply, look, I can just drag it here and then call construct object from class. And now I can select any object I want. But in this case, I will just type widget in. And you can see here is my BP promotion selection widget. And that's just a UI inside of Unreal Engine. So that's how I created this part here. Let's quickly connect it again to make sure it's there. And now we have another logic that sets our images. And those images are then set inside this widget. Let's quickly have a look at the widget. The widget is inside the blueprints folder. So we can go to BP_promotion selection widget. If you want to have one on your own, just right click, scroll all the way down, go to user interface and take a widget blueprint. I always recommend using a user widget. You would have different parts here as well, but I've never used any of them except for this user widget. So you can just create one by clicking onto it and it will look like this. So that's the widget. Here we have some of the buttons already included. So you can click onto them to select that you want to spawn a knight, a rook, a bishop, or a queen. And we also have some images underneath them, and they are just scaled correctly so they look good inside of here. The next part is then that we have a designer and a graph. And the graph is the option to actually tell the widget what it should do. So on event construct, we want it to fade in. And you can see we want to play back this thing forward, play animation forward. And now you might wonder, where can I find this animation? And I always forget where it is. So that's not only a problem you will have. So go to designer, go to animations, and now you can see there is a fade animation. And what you can do now is you can simply press the space bar to activate it and to see what it actually does. And you can see it just fades in our widget. So we have to set here, and then we can just play it from there, and it fades in our widget. So that's our fading logic. Now you have to deselect this part, otherwise you won't be able to see that part. You can see. So just click onto here to see it again. And now we have our selector right here again. The next part which is relevant, and which I have to explain at least a little, is that you have to use a canvas, and this canvas then allows you to set a location, offset left, offset top, offset right, offset bottom. And you can also do that with anchors. So you can set the anchor to, for example, right side, middle side, and so on. But that's only possible when you have a canvas dragged into here before. And you can just do that by typing in here canvas. Now you can drag and drop the canvas panel into here, and that would work for you. Now we want to have something inside our graph to play with. So we want to have a click logic for our queen selector. And that's just done by here. We first select it's focusable. And we also want to have a click logic activated. So when we go down here, you can see on pressed is an event already set here. And this on pressed event is just in here. And now we can call set promotion, which is a function I just created. And we want to promote with a Q. Here we want to promote with a B because we selected a bishop. When we select a knight, we want to promote with an N. And with the rook selector, we want to promote with an R. So that's just a part of it. The set images you have seen here. is also inside of here, so it just shows us whether we are white or not. And we have to start in target field to then get back to our pawn. And let's quickly have a look at set promotion part here. So what does it do? First of all, we play the animation in reverse. Let's have a look at how this looks like. So go to, not the content drawer, but animations down here. Go into fade. And now you can play it from the back. So look, this would just be what it does. It just fades out as it faded in. So let's go back to the graph. Here we have our set promotion function. So we play it back. Then we check if we are white. If we are white, we just use the letter we provided as a promotion here because it should be uppercase. And then we call promotion chosen on our pawn. And we just give back our start field, our target field, the widget, and the promotion. And if we are not white, then we are black. We have to lower case the promotion and also give back at the pawn. We call our event promotion chosen, and then we call start field, target field, and we give the widget in to then go into here. And that's what happens when the promotion is chosen. So we wait for a second to actually be able to get rid of the widget before we remove it from its parent. And removing from the parent just means it removes it from your screen. It's also something I should have told you in here because we have to add it to the viewport first, then it will be shown on your screen, and afterwards we have to get rid of it again when we go into here and remove it from its parent. So the promotion is then set inside of here, and we update the board on pawn promotion just as we do with the AI. And with that being said, we just call the despawn. We set our field, the present chess piece on our field, to none, call the despawn, and then get the square by name where we are currently located on and call on pawn promotion initiated. And that's the same logic as before. We just wait 3 seconds, we destroy our actor, then we call we want to spawn in another chess piece based on the fencer. So imagine a queue here, we would spawn in our queen at the location of the field, and then we just set this chess piece we just spawned as a reference on our tile. And then we initiate the next move for the game mode. So that's already what's included. And now we can also add something down here to make the capturing a little bit more interesting. Let's just finish the logic of our chess. Then we're done completely. And we also have some nice little add-ons like an explosion when we capture someone and this little spiral when we promote a pawn to something different. So what we have in here is the last part which is missing. And this is how can we detect that we captured someone. And that's simply done based on the begin overlap part. So if we overlap with something, this event is triggered, and you can simply get it by calling on begin overlap. I think is the right part. Yeah, event actor begin overlap. You could also have that set for only the collider, for example. So once we select the collider and then right click, we only have the options available for this collider component. And then we can go on to add event for collider, collision, and then you could just check for a collision with this collider and not for the whole actor. But in our case, the whole actor is totally fine. So let's use that. And now we get a reference to our other actor. First of all, we want to check if it's a chess piece. It could also be a board. It could also be something like the nav mesh. So just to ensure we are colliding with a chess piece, we actually check for the chess piece and then get the static mesh of that chess piece if it's valid, and then get the material of that static mesh. So quickly have a look at that. Click onto static mesh here. You can see it's the queen mesh here, and it would have a color either white or black. And in this case, we would then get element 0, what you can see here. So the material one can be added here. So you could have multiple materials in one mesh, but in this case, we only have one. So we search for element index 0, get the material which is currently there, and then check it against our own material. And if this own material is not the same as our opponent's material, then we have a collision with a chess piece that's from the opponent. and thus we can get captured. The next part we have to think of is that we can only be captured if we are passive. So if we are attacking, we can only capture, and we can only be captured if we do nothing. So if we are not attacking and we are not the same color, so the opponent's chess piece we collided with and our chess piece are not the same color, then we are captured. And what does capture do? That's at the moment very boring. It just destroys our actor, and that's not pretty cool, is it? So let's change that very quickly. First of all, we have to get a do once node here, and we can simply get it from there. Then we call do once. Why do once? We only want to capture one time, not 2 times or 3 times, because the collision could happen every frame, which would then mess us up. So we just call do once. And from the do once this is completed, we want to set the collision enabled. And to do so, we get our collider. And then we get the set collision enabled. And we simply set the collision to no collision because we don't want it to have any collision anymore. Then we can't collide multiple times with it, right? Afterwards, we want to call the destroy, which is our Niagara system. And let's quickly have a look at how this looks. So we auto activate it, and that would be what happens when we capture somebody. It will just explode and then disappear. So that's what we want to have. Let's go back to our event graph. We can just drag and drop the destroy from here. And with that destroy, we want to activate it. So we call set active. And now we want to set it as active. And the static mesh, which we currently have here, we just drag and drop in here as well, should be set to hidden in game. So set hidden in game. Then the static mesh is disappearing, but not gone completely. And after that, we want to wait 2 seconds. So we just add a delay here. Delay of 2 seconds. And with that, we complete our actor destruction. And that should be it to actually capture someone and triggering an explosion. We can also do it not only once. So if we then go like this, which doesn't make any sense, but then we could reset it and do it another time. In this case, we don't need it because it should only happen one time. And that's exactly what we aim for. Cool. That's just how we can make it a little bit more unique. Let's test it together. The last thing we always want to ensure is that we haven't any bugs inside of our game. And to do so, we have to test them. So we can go to the content drawer, then go to the game mode chess, which is underneath the blueprint section here. And then we just have a look at the event begin play. We see we get our game state, and then we initialize our chessboard with a certain fence string. And this fence string can be changed inside the construction script, for example. So let's just go down here a little bit on the left side. And now we pick our fence string, and we want to set our fence string. You can see this fence string is just the starting fence string. And we want to set it with our test fence string here. So we quickly get our test fence string in here. Let's quickly have a look at this as well. And it's just a certain position 10 moves into the game already, where we can castle, promote, and also have an EnPassant for both sides. Let's quickly compile and save that. Now make sure that both players are non-AIs. So let's quickly tick there, check there. Okay, there's no tick anymore, so we can save that. That's also the option to play AI versus AI or player versus player. You can just tick and untick it as you like. And in this case, just to test it, it's easier for us to just test it with 2 players. So we can actually do both moves instead of only one. And now let's try the EnPassant for black. So I just move forward with this white piece here. We check it with the black piece and it gets destroyed. Perfect. That's exactly what we want to see. Now let's promote this piece here. That also works. We get asked what we want to promote to. Let's quickly take the knight. I don't care. And it will be spawned in. All right, it also faces the right direction. That's exactly how we want it. And now we can check if the EnPassant also works for the white side. So now we can capture this pawn here by moving here. And also this is working perfect. That's exactly what we want. Now the next move would be to check if the promotion works also for the black side. Let's quickly do that. We get asked what we want to put in. Okay, let's go with a queen this time. So this piece should be promoted. We already see the Niagara system, perfect, and the queen gets promoted. Now we also have the castling availability, so let's check that quickly. We can castle here, and that works as well, perfect. And also, let's try it here, and also this castling is working. That's pretty cool. Okay, so that's both working. Let's just ensure that a normal move is also working. Let's move there with the knight, and let's move here with another knight, and all of this is working. That's perfect. That's exactly as we like it. And also try a pawn. Seems to also work fine. And here we have the same. All right, perfect. So normal moves and special moves are all working. Let's quickly go into the game mode again and play AI versus AI to see if someone wins. Let's go to the player details and just take both of that. So we play AI versus AI. And now we will actually see that the promotion is just happening on its own and Stockfish decides what he wants to promote to. Let's quickly have a look at that as well. That works, it seems like. And now we have just the moves done by Stockfish and not by us anymore. And you can see Stockfish moves. We don't get asked for promotion and it just turns the queen or the pawn into a queen. And this seems to work as well. Perfect. So that's just how we want it. Let's do the last check, and that should include how we can check our debug draws, such as if we have a draw or a game over. So a checkmate, you can see that's the checkmate here. Let's try that out with a fence string. To now check if we actually have a checkmate, let's quickly go to leadchess.org and go to the builder. And what you can see here is that you actually have some options. So you can go to Tools, Board Editor, and then you can go to Set the Board, and then you can go down a little bit. And there is a section called Endgame Positions. So in this case, we could just take the mate, queen, and rook, and it will just set the black king here into checkmate. Let's quickly check that. We get our fence string from here. Use it as our test fence string like this. Compile and save. And everything should be built as we used to. And you can see Stockfish already tries to set the other part into check. Let's quickly check if this works. But it seems like it's already cornering it, so that's exactly what we need. Let's see if he actually finishes the job. Now he's also closing in with the king. And that should be it now. And of course, this part works. And now we would just reset the board and everything would start from the beginning again. Cool. So now we know also that our logic here works. And for draws, we don't have the time, but I can guarantee you that works also because we just check if we have reached 100 half moves and there is no bug included in that logic at all. The last part before the outro, as always, is to check our current project progress. And you can see we just finished the whole chess party setup. We just built our console program. Now we included also a complete 3D chess in Unreal Engine. And the next time, we just want to advance to the physics and projectiles section, where I will actually show you how you can handle physics-based collision and also projectile-based collision. Congratulations! That was the whole chess party part. I hope you liked it. I really hope you now know how Unreal Engine works. You understand a little bit better how you can actually set up blueprints, how you can connect nodes with each other to create code, and how you can also implement C++ code into Unreal Engine and the functions you use in there from the code. I hope you also know now how you can move something using AI and that you're not afraid of Unreal Engine anymore because it's absolutely handleable. It's quite hard to get into it, I know, but I hope I could give you a little bit of a easier entrance than just watching videos from somewhere else where not one finished project is the result at the end. With that being said, I'm very much looking forward to the next part where we will actually have a look at physics-based collision. And yeah, thanks for your time. Thanks for your attention. See you next time.